All right. We got kind of focuses on. Okay. So guys, again, we skipped 2-1. We're gonna just jump into 2-2. We are talking today about variation. Is that something that you guys have talked about in algebra classes before? Direct versus inverse variation? Yes, no, maybe? Okay, no. Maybe. Okay, we'll find out. This is not super important. We're not going so in depth with it. We're gonna skip around on a couple of things, but the biggest thing I want us to kind of take out of today is direct versus indirect variation or direct versus inverse variation. Direct variation is written in the form of y equals k times x. That k is a constant. So it could be y equals 2x, y equals pi x, y equals whatever, something times x. A real life example that we may have seen already is area of a circle. Area equals pi r squared. So my constant there is pi. Pi is like an actual number. And we're doing y equals a constant times our x. Your x can have an exponent, that's totally fine. It can have a power, we don't care. Inverse variation, on the other hand, is written as y equals k divided by x. So there's a division sign instead. We still have our constant of k, so I will label that k is your constant. And again, I told you my Apple Pencil didn't work, so we are really working with trash handwriting, and I apologize. Let's be honest, my handwriting is never that great, but it's going to be really rough today. Constant. My inverse variation, I believe this is a physics formula, but truthfully, I've never taken physics. F equals k over d squared. See how we have a division mark? That's the biggest thing. Inverse means that we've got dividing, the constant is on top, the variable is on bottom. Direct variation, the constant is being multiplied by your variable. Okay, so we're just kind of working with that today. The other concept I want to talk about before we get going on problems is something called the power function. Power function means your exponent, right? So it just means that your x has an exponent. So it's any x has an exponent. So we can think of it as y equals k times x to some power. And I'll just use like a little a to represent it. Can be any exponent. Now your constant k could just be 1, your constant k could be a real number or a bigger number or fraction, but we have a constant and then we have an exponent with our x, okay? So we deal with power functions a lot, and you guys are actually probably very familiar with some. We have some BFF graphs that are power functions. What ones do you remember that have exponents? What's wrong? Charlie was ready to go. Charlie the bug slayer. Okay, sorry for that. Kind of that time of year, the bugs start coming inside. What'd you say? That's disgusting. All right, now going back to power functions, which BFFs have x's with an exponent? Squaring, good. Cubing. I can think of a few more. So like some of them have x as the exponent, so exponential, x is the exponent, so that doesn't count. We'll talk about that in chapter 3. I would argue linear, like our identity is. What's its exponent? 1. I've got 2 more that kind of have like hidden exponents. Square root. Do you know what the square root is as a exponent? 1/2. X raised to the 1/2. Then there's one more kind of hidden one. It's my reciprocal function, because that's going to be x to the what power? -1. -1. Get that negative sign up there. Good, so these are all examples of functions that have an exponent on or x. Cool, so we're gonna deal with power functions. We are not gonna do this part right here. I'm gonna publicly apologize to F period on my Zoom because we struggled through it. It was not good, so we're just not gonna worry about that. We're gonna move on to the next part. Number 17 through 22, these all say write the statement as a power function equation. Use k as a constant of variation if one is not given. Okay, they're all power functions, but they are all are going to go with either our direct variation, which is y equals kx, or our inverse variation, y equals k over x. So they're all going to follow one of those patterns, and it's going to tell us in the directions, okay? Okay, so it tells us the first one. If it doesn't give us a constant for variation, we're going to just use k. The first one says area A of an equilateral triangle varies directly as the square of the length s of its side. So first thing I see the word direct variation. So that means I'm going to use my direct variation. My y I can replace with that A for area. I don't know what its constant is. It doesn't give me a constant, so we're just going to use k. And then my x is the s for sides, and it does say the square of the length of s. So s squared. Okay. Number 18, the volume of a circular cylinder with fixed height is proportional to the square of its radius. Proportional is another way to say direct variation. So we are going to keep going with that direct variation idea. Instead of y, we'll write v. I actually have a k in this one. I didn't see it earlier, but it says fixed height. So my k, we're going to use h. And then my x is square of r, so r squared. Okay, you guys hanging in there? Are you doing okay with this? Okay. The next one says the current I in an electrical circuit is inversely proportional. Oh, okay, now we got to switch ideas. Inversely proportional, we're going to use the inverse one, to the resistance R with a constant of variation V. Okay, so this time I'm going to write I equals, my constant goes on top, so my V goes on top, and then my variable is my resistance, my R, it goes on bottom. Doing good so far? Okay, next one, Charles' law states the volume V of an enclosed ideal gas at a constant pressure varies directly. Okay, that's the key word I was looking for, varies directly as the absolute temperature T. Okay, V is my Y. It says constant pressure, so I'll use a P for my constant. And then it says absolute temperature T is going to be our X. Doing okay with that so far? Last two. The energy E produced in a nuclear reaction is proportional, that's my direct variation, to the m mass with a constant of variation being c squared, the square of the speed of light. So this one is still direct variation. E is my y. My constant this time is c squared, and then my variable is m. And then last one, it says the speed p of a free-falling object that has been dropped from rest varies as a square root of the distance traveled d with a constant of variation k equals square root of 2g. It just says varies, it doesn't say inversely varies or directly varies. We get to assume direct variation. So if they don't tell us, we assume direct, and we will say, okay, p is my y, my constant is root 2g. And then my x is also the square root of d. So you can put them in separate square roots, or you could put them all together under one square root when you multiply them together. So p equals the square root of 2gd. All right, doing okay? All right, go ahead, flip your paper over. The rest of what we do today is mostly what's on your homework. So if what we did earlier isn't fitting great in your head, what we're doing now is on your homework. I am also going to write this really small next to this, but feel free to use like the actual space that you have on your paper. So these say determine whether the function is a power function. given that C, G, K, and pi all represent constants. So that is an important thing to know. C, J, G, K, and pi all represent constants. And if we say, yes, it's a power function, we're going to state the power and we're going to state the constant of variation. Okay, so let's look at number one. We'll just kind of go on this column first. Number one, is that a power function, yes or no? Yes, I'm just gonna put a little check mark next to it. What is the power? 5. It's got a fraction, but the x has to be in the bottom to be inverse. My power is 5, and then the constant of variation, what's the constant? -1/2. I might even set myself up with a little bit more organization. Oh, that's way bigger. And this is my power. And this is my constant. All right, what about number 3? Yes or no? Is that a power function?
Yeah.
Does it have x with an exponent? X is my exponent. That doesn't count. That's an exponential function. So we're going to move on from that. Okay, what about number 5? Is this a power function? Yes. Now I will tell you that C is my constant. So what's the power of this one? Not 2, because C is the constant. So C, we'll even write C squared as my constant first. M is my x. So what's the exponent on M? 1. Very good. It's just 1. I only know that because we just did that a second ago, so I knew to go back to the directions and look what counts as a constant. So C counts as a constant. All right, the next one says, oh, we did this already in the other class. That's okay. D equals 1/2 GT squared. What is my, is this a power function first? Yes. What's my power here? It's T, so it's the 2, and then what's my constant? G, and then also bring that 1/2 as well. All right, what about 9? It is inverse, but I would still argue that it is a power function. What's the constant here? The power is going to be that 2, the constant's just K. My power is not just 2 though. Remember when it's on the denominator, it becomes a negative to bring it up. So my power here is -2. I'm going to jump over to the other column. We'll do those other 5. Everyone doing okay so far? Okay. All right, number 2, is that a power function, yes or no? Yep. What's my power? 5/3. What's my constant? Good. Just 9. I don't remember how I labeled number 4. What do you guys think for number 4? Number 4. I hear some no's. Let me see. Did I decide it was a yes or no? Ooh. I decided it was a yes. Why do you think I wrote yes for this one? Not a power of 1, a power of, you don't see it, power of 0. So I'd say a power of 0 and a constant of 13. What about number 6? Yes, what's my power? Good, what's my constant? 1/2 K, very good. What about number 8? Yes. What's my power? What's my constant? 4/3 pi, awesome. And then last one, what do we think? Yes. Do any of you know which one my X is right here? Which one? I think it's A as well. Rosie, why do you think it's A?
I think my reasoning is,
It might be, but I agree with you. So tell me your reasoning.
I think like in statistics, like AX plus B is what you use for the limit progression, we just learned that, so
Okay,
I don't think so.
that's not how I reasoned it, but I understand what you're thinking. Anyone think they know why I think it's A? Not because it's second. See how the problem says f of A? When we do functions, it's usually f of x, so I think that A is my x. So that means my m is my constant, and that means my exponent, my power here is 1. Awesome. You guys are rocking this. All right, let's keep rolling down. We've got 2 more little word problems. That's all we're doing today. These word problems are still using our direct and our inverse variation. And this is what you'll see on the homework. This is also if I put a question from this section on the test, these are the types of questions that I would put on a test. So the first one says volume of a gas varies inversely as the pressure. Okay, we're gonna team time out there. Is this direct or inverse variation? Inverse. So we're gonna use our inverse equation. We're gonna think about y equals k over x. In this case, what variable is my y? I always write y first, so what's the first thing that was told to us in the sentence? Volume. So we're gonna say V is my volume, that goes first. We don't know what my constant is, so we'll keep that as a K. And then my X is what? It's for my pressure, so I'm gonna use a P. I needed to set that up correctly first in order to be able to plug in and solve. So the next statement says the volume is 9.2 and the pressure is 163. So we're gonna plug in 9.2 for my V, we're gonna plug in 163 for my P, and we're gonna solve for K. So I get 9.2 equals K. Over 163. So we solve for K, multiply by 163 on both sides. And I get 1,499.6. That's just my constant, okay? I'm not done yet. We need that constant though, because the next part of the question says find the volume when pressure is 74.1. So that means I still have my original equation. I'm still doing V equals K over P, but now I have my constant. I've got my K is 1,499.6. I've got my pressure is 74.1, and I don't know my volume. So we just plug those pieces in. We're going to divide those two numbers. And we get volume equals 20.2. We'll leave it like that. I don't know what my units are here. It's just 20.2. Well, it's volume. Yeah, and I don't know. Yeah. Yeah, and it doesn't tell us what it is. So we'll just leave it at 20.2. Okay, cool. All right, moving on. Let's do the last one. Okay, this one says the weight of a football player varies directly as his shoe size. Okay, pause. Is this inverse or direct? Direct. So we are going to use the concept or the formula of y equals kx. Okay. Which one is your y, the weight or the shoe size? Y goes first in the equation. What's the first thing that was mentioned? Weight. So we'll say weight. And then K is my constant, and so X is my shoe size is my X. So I'll put a little S there. I generally hate writing S's because it looks like a 5, but it'll be fine. It says Joe weighs 182 pounds and wears a size 11.5. So let's put that in. So let's put 182 equals K times 11.5. Okay, so we'll solve for K. We'll divide by 11.5. 182 divided by 11.5, and I get 15.8. So that's my constant. Now the next problem, or the rest of this problem says John wears size 13. So how much does he weigh? So now we can plug 13 in for our S, 15.8 in for K and then solve for W. 15.8 times 13. 15.8 times 13 is 205.4. That's all we got. Okay, yeah, big clap for ourselves. Clap for ourselves. We was doing that yesterday.
Like,
oh yeah, we love
me.
me.
I don't know, he said, he's like.